will be installing Kubernetes for learning, not for production. When you focus on learning, you keep your options open for all possible alternatives, while in a production install, you usually are governed by requirements. In our case, the only requirement is to have a cluster running and to be able to host applications or workloads on it. Kubernetes is not an operating system. It is an API that handles containerized applications, which means that we will need an operating system and a containerization technology. Kubernetes can work with multiple operating systems and with multiple containerization technologies. So we have to make a choice. Kubernetes can also work with multiple storage technologies and with multiple networking implementations, which enlarges our choice pool. Luckily, we are doing a spiritual install, which allows us to experiment and try multiple options. Here are the choices I made. I selected to install Kubernetes on Fedora, which is the most stable and up-to-date Linux distribution as far as I know. Stable and up-to-date, not stable only, not up-to-date only. The Fedora packages for Kubernetes were restructured in Fedora 40, which is still in beta. It will be released next week. I wanted to test the new packages, so that's why I selected to install Kubernetes on Fedora 40 beta running as a virtual machine on the KVM hypervisor inside my Proxmox based DevLab. Kubernetes servers are called nodes, and you usually need multiple nodes in a production install, even in a learning install. But the best practice is to install all the nodes that you need, that you know that you need at once. In my case, I will install a single node and experiment with storage and networking, and then add other nodes when I feel I am ready to expand. Let's see how to install Kubernetes on Fedora 40. First, I added the Fedora Server 40 Beta ISO to my ISO storage, then created a new VM from it using hardware-assisted virtualization because my DevLab is configured to support it. There is a video that I will link in the description on how to configure a DevLab on Proxmox to support hardware-assisted virtualization. I have selected to run this instance on 4 cores, 8 GB of RAM, and a system drive of 10 GB. Later on, I will add more storage. In my DevLab, I implemented a DNS automation scheme that I mentioned also in a previous video. So my VMs and containers get predictable IPs based on their Proxmox VM ID. And my new Fedora 40 VM will get the IP 192.168.1.150. After installing the OS, I connected to the new VM using SSH and updated all packages, then started following the install guide on Fedora's website. As a long-term user of Kubernetes, I found that many of the steps, they did not make sense to me. So I changed some steps and I changed the execution order a little bit so that they make more sense to me. But the general idea is still the same, and it managed to install Kubernetes successfully in all my tests. The instructions include disabling the swap memory and the system firewall, then installing the legacy IP tables packages, probably because it is a dependency of some network plugin. Then loading 2 kernel models and applying a few kernel configurations. The commands that I am using here are all documented in an article that I will link in the description of this video. After preparing the VM, a reboot will be required to verify the kernel configurations have been applied permanently. And this can be tested with a few commands after the reboot. Kubernetes supports multiple containerization technologies, and the official documentation mentions 4 supported containerization engines and says that starting with Kubernetes 1.30, Kubernetes will support any containerization engine that conforms to the Container Runtime Interface CRI. Since we are using Fedora packages, not the official Kubernetes packages, we will be running Kubernetes 1.29, which is the latest version supported on Fedora 40 right now. The supported containers for Kubernetes 1.29 are Containerd, CRI-O, Docker Engine, and Mirantis Container Engine. I am an old user of OpenShift, so I will use CRI-O. as my first container engine for now, but in the future I will change it to test the other engines as well. I installed Creo with the command that you will find also in the article that is linked in the description of this video. After installing Creo, we are ready to install Kubernetes packages. We first start by installing the packages, and notice that I am not installing the Kubernetes client. I'm installing only Kubernetes, the base packages, the common packages, and the administration package that I will use to initialize the cluster. So the client will be installed on a different machine. Also, the installation that you see, the commands that you see here are designed for Fedora 40. They are different from what you would do normally on Fedora 39 because the Fedora team changed the structure of the Kubernetes packages on Fedora 40. If you are installing Kubernetes on Fedora 39 or earlier, you will need to use different commands. Kubernetes supports multiple ways of deploying applications to it. I will start with Helm now, but I will add other options to the tool set while we progress in the series. Helm is a Kubernetes package manager and works as a CLI app that you can connect to multiple package repositories. A Helm package is called a chart, and a Helm chart is a collection of YAML files that describe the Kubernetes resources you want to deploy to a Kubernetes node or install. I have installed the Helm CLI on a specialized LXC container running in my dev lab outside Kubernetes. And I'm calling it my Helm controller. On the Helm controller, I will have also the Kubernetes client. When Helm is installed using the package manager, normally the Fedora package manager DNF, you need to give it access to Kubernetes, and you get access to Kubernetes from a configuration file that you can find on the master node on the control plane. I copy this file using SCP to a specific directory, which is .cube under the home directory, under the user's home directory, and the file name should be named config. The first thing we need to do is to create a base namespace so that we can put our base configurations that we will set up in the next episode. Because of the modularity of Kubernetes, a bare install of Kubernetes cannot do much. It lacks the storage configuration, it lacks the network configuration. Those topics require some discussion, and we will focus on them in the upcoming videos. This first node of our Kubernetes cluster is ready for configuration, and we need to choose a storage plugin, a network plugin, and that is what we will do in the upcoming videos.